Good morning. A little explanation before we get started today. I am recording this lecture in my house, specifically the kids' playroom. So as a consequence, you can see that the chalkboard that we're going to use is a little bit lower than I would like it to be. It's great for the kids, but not so much for convenient use for me. So if you're seeing the voice coming from outside or you're seeing my head kind of chopped, sorry, I'll try to work on that. Anyways, what I would like to talk about is to finish up the third book depreciation method that we didn't get to in class last time. If you recall, we talked about the straight line depreciation method and the declining balance depreciation method. Those are the two most common methods used, but there's also a third method that gets used from time to time, but you will probably not see it as an electrical or computer engineer. And it's called the units of production method. Now, straight line depreciation is valid only when the fixed asset is used for the same amount of time each year, or at least expected to be used for the same amount of time. Because you're assuming that the asset is being consumed in a very nice time phase pattern. And same is true for decline balance. Decline balance is based on straight line, but we're trying to fast forward the depreciation expenses in order to get tax benefits. Now, if we are looking at something that is being consumed unevenly, let's say in year one we have a consumption of 1,200 service units, and in year two we might go to 500, year three we might see 750. That we're bouncing all over the place. That is not a uniform consumption of service units. In these particular types of circumstances, it might be to our benefit to utilize a units of production method. What we do is that we try to estimate the total number of service units that the asset will be consuming over its lifetime. Then the depreciation that's used in year end would be our estimate of the service units consumed in year end over the total service units. That gives us a fraction of the overall use, and then we take the cost of the asset and we subtract the service value. So that gives us a nice fraction. The people who do the actual bookkeeping, the actuarial, bean counting, they hate this method because this is not something that is easily done ahead of time. When we look at straight line and declining balance, those are things that once we put the parameters down, we can put everything out. Whereas here, if you're really being accurate, you're waiting for the actual number of total units being consumed in that year. And that's not really liked by the bookkeepers. So that requires the collection of data for machine usage that's not well looked upon. Accounting methods as a result of that are a bit on the tedious side compared to the other two methods. But this is something that does have advantages where if you're dealing with differences in volume and you want to have the accuracy, it does give you a more accurate portrayal of the utilization of that asset than the other two methods. It's very good for when you are depreciating equipment employed to exploit natural resources if the resources will be depleted before the machine wears out. Because in that case, what you would have is you have probably a good idea as to how the depletions of the resources will occur. You will figure out the total amount of service, say for example, amount of coal in a mine, and how much you expect to get out each year. At the end of the project, you would still have a value associated with that asset that could be sold or utilized in another project, and this will allow you to do the depreciation in a pretty nice way. So it's not considered practical for general use in depreciating industrial equipment, but there are some places where it does get used, so it's good to be aware of this particular book depreciation accounting method.